Every December, something unusual happens. The world doesn't stop, but it softens. Deadlines feel less sharp, our voices drop a little lower. Even cities seem to breathe differently. Lights appear where there was darkness, stars show up in our homes, and songs we haven't heard all year long, seem to return to our playlists. And for a brief moment, time doesn't behave the way it usually does. Behind much of what we call Christmas magic, there is some math. No, not the kind of math we see in our textbooks, not the kind of math we see in our exams, but the math of watching the world carefully and refusing to look away. We like to imagine the star as a spotlight, a beam from the sky pointing neatly at a stable, as if the universe itself wanted the directions to be easy. But ancient astronomers, they weren't looking for spotlights. They were looking for patterns. In the Gospel of Matthew, it is recorded, "We have seen his star in the east." That sounds like poetry to us, right? But to a Babylonian or Persian astronomer, that was technical language. In the East, that was technical language. In the East actually refers to a heliacal rising, which is the first visible appearance of a star or a planet just before sunrise after it has been lost in the sun's glare for a period of few weeks or months. And this wasn't guesswork, because astronomers in Babylon and Persia kept meticulous records of the sky. The changes, the repetitions, the cycles, they tracked all the movements. So when something as unusual, as rare as that heliacal rising would occur, they didn't just look at it and go, wow. They said, this means something. And around 7 BC, the sky did something rare. Jupiter and Saturn, Jupiter the planet associated with royalty and kingship, Saturn the planet associated with protection and authority, they both met in the constellation of Pisces. Pisces is a constellation that is associated with the nation of Israel. And this did not just happen once, it happened 3 times in that same year, in May, in September and in December, a triple conjunction. To the Magi, this was not a miracle that interrupted nature, it was a message that was being sent into nature, and messages like that demanded action. So they prepared to travel. We place the wise men beside the manger because we like tidy stories. But tidy stories are rarely true. The distance from Babylon or Persia to Bethlehem is between 1500 to 2000 kilometers. So if you assume that a camel caravan would travel at 20 to 25 kilometers every day, that would give us 45 to 65 days under ideal conditions. More realistically, 2 to 4 months, because we are assuming that they knew where they were going. They probably had to stop over many times to recalibrate. And history supports the delay, because when King Herod hears from them about the star, he orders the killing of children under 2 years old. Why 2? Because that's how long the sign in the sky might have been. Matthew uses the Greek word paidion, meaning young child, not infant. So by the time the Magi have arrived, that stable is likely empty and Jesus is no longer a newborn. That changes the story slightly, right? Because Christmas was never meant to be a single frozen night. It was always a process of noticing, of traveling, of arriving late and still arriving. At some point, Christians started to ask a different question. Not where, but when. The Bible doesn't give us an exact date for the birth of Jesus. So early Christian scholars tried to calculate one. They worked backwards to estimate the birth of John the Baptist, the Jewish priestly service schedules, ancient historical traditions. Some arrived at March, some April, and some even suggested November. There was no consensus. But by the 4th century, the Western Church had already settled on December 25th. Not because they were certain, but because it was meaningful. It fell close to the winter solstice, the moment when days stop getting shorter and light begins to return. That symbolism was irresistible. But the story doesn't end there, because time itself refused to cooperate. The calendar in use for centuries was the Julian calendar introduced by Emperor Julius Caesar in 46 BC. This calendar assumed that the year was 365.25 days long. The actual length of a year is 365.242189 days, a difference of just 11 minutes, almost nothing, until it isn't. That error adds one extra day every 128 years. So by 1582, the Julian calendar had drifted 10 full days from the seasons. Spring was no longer spring. So Pope Gregory XIII intervened. 10 days were removed. Leap year rules were refined. And then the calendar snapped back into alignment. This calendar became known as the Gregorian calendar, and this is the calendar that most of the world uses today. But calendars are not just mathematical tools, they are acts of identity. Many Orthodox churches chose not to switch, not because the math was better, but because tradition mattered more to them than mathematical precision. So, December 25th in the Julian calendar became January 7th in the Gregorian calendar. Same celebration, different clock. By the time Christmas reached our living rooms, it had already passed through the sky, the road, and the calendar. And something interesting happened. The story stopped being written by astronomers and priests and started being written by ordinary people through songs like the 12 Days of Christmas. It sounds playful, almost silly, but listen carefully to the lyrics. Each day does not replace the previous day. It layers. The gifts don't disappear, they accumulate. On the first day, you receive one gift. By the second, you receive two more. And by the third, three more, and everything before it. Mathematically, this is not repetition. It's a triangular sequence. 12 plus 11 plus 10 plus 9 plus 8 all the way till 1. That's 78 unique gifts. But that's not what the song does. The song repeats all earlier gifts every single day, which means the real total is 364 gifts, one for every single day of the year. A Christmas song that accidentally encodes the idea that celebration should spill beyond a single date, that joy should accumulate, that the story doesn't need to reset at midnight. By this point in the story, math is no longer just in the sky or the calendar. It's inside of us. Take Secret Santa, for example. In a group of just 10 people, the chance that no one picks their own name is only about 37%. We think it's a social problem. Awkward silence, nervous laughter. Someone says, "Of course, I picked my own name." But it's not bad luck. It's probability. There's 63% chance that at least one person in that group of 10 will pick their own name. Not because people are careless, but because of randomness. Randomness behaves that way. Christmas games quietly, silently teach us something very important, that when groups get bigger, coincidences stop being rare, patterns emerge. That discomfort, it's not personal, it's mathematical. And then there is Santa. Just one night, but every time zone. Hundreds of millions of homes. From a mathematical standpoint, this is absurd. It's a version of the traveling salesman problem, one of the most difficult optimization problems ever known. The challenge isn't speed, it's choosing the best possible path from an unimaginable number of options. Even modern day computers can't solve it perfectly, but Santa does it effortlessly, which tells us something profound. Santa is not a logistical claim, he's a permission slip. A reminder that once a year we suspend optimization, we choose generosity over efficiency, wonder over realism, and stories over solutions. So when you strip away the decorations, the carols, the dates, and even the myths, what's left is something very, very human. People watched the sky, they counted days, they traveled, they argued about calendars, they told stories, they sang, they played games, they believed. And math shows us how carefully this magical story was carried across deserts, centuries, and cultures without ever breaking. And somehow, after all the counting, we still celebrate the wonder that is Christmas.